Good afternoon, everyone. Thanks for coming to the Ask the Architects panel, or Ask the Java Architects panel. So unfortunately, Maurizio Cimanamore was going to join us today, and he fell ill and was unable to come to the conference. But also on the panel, we have Brian Goetz on your left, and a special guest today, Ron Pressler, who is working on the Loom project with us, still was in town. So we said, hey, Ron, join us on the panel. And I'm Stuart Marks, also known as Dr. Deprecator. So here we are. So this is our Ask the Architects panel. Very short safe harbor statement. A lot of our answers might be speculative. Do not base any product decisions on them. All right, so we will be taking questions on Twitter primarily. Please ask them with the AskArch hashtag. I'll be monitoring Twitter for questions. Now, it may take a little time for questions to roll in. Do we want to have people shout out the first few questions and we'll try to do that? Okay. So the format is completely Q&A. So if you have questions, so let's take some questions from the audience first to start off. Anyway, the format is all Q&A, so that's what we're going to do. So we'll dive right in. Anybody have any questions? Raise your hand.
If you don't have questions, it's going to be very boring.
Yeah.
We're still going to make you sit here for 30 minutes.
Yeah.
What's the relation between serialization and Valhalla? Inline types? Problems?
I'll repeat the question. The question is there a relationship between serialization and value types in Project Valhalla? And there's this sort of predictable cycle you observe when you talk about the interaction between serialization and any new language feature. And the first stage is denial. So in the denial stage, you say, oh, we're just not going to let them be serializable. And that lasts for a few minutes until you realize, yeah, that's not really an acceptable answer. We went through that same thing with lambdas. We tried to get away with, well, what if they're just not serializable? And then when people finished laughing, we had to think about how we were actually going to do it. So the value types present similar interaction challenge with serialization, but it's reasonably straightforward. The value types are classes, so they have fields, and old serialization works by scraping fields. That's a little less comfortable with value types, but it's theoretically possible. I outlined a potential new direction for serialization, in the talk that Stuart and I did this morning, which is a sort of leaning on constructors as a way to deserialize objects that would work perfectly well with value types. So it's probably going to be something more like what we outlined today, rather than trying to retrofit existing serialization. But at some level, they will have to be serializable because it would be too inconvenient if they weren't.
The problem if it's in line, if the value type is in line in another class.
So the question is, well, how does that work if the value type is inline in another class? It's the same way it is with any other class, right? So if you have a field whose type is X, and X happens to be a value type, well, in the process of deserializing the object that contains X, you're going to deserialize the object for X and then write the field. If that object is of reference type, it's writing a reference. If that object is of inline type, then you're writing the full inline value into the layout of the object.
Okay, one of the nice things about taking questions on Twitter is you can weed out the troll questions, like the ones from Real Devox Trump. Anyway, but we do have a good question that came in. Somebody's asking the status of Project Portola. Do we have anything to say about that?
So Project Portola is container-friendly, right? So
that's the Alpine Linux.
Alpine Linux, right?
Right, so, but it is, that's part of the deal.
So there's a prototype of the Alpine Linux port that was done probably a year or more ago, and I don't think a lot has been done with it since then. It's at it seems to work proof of concept stage, but I don't think a decision has been made about whether to move forward with it as a supported port.
Right, so I don't think it's currently supported in OpenJDK, but there are OpenJDK builds from vendors other than Oracle that do have an Alpine Linux build.
Okay. So there's a question about can we reasonably get rid of checked exceptions, which I think we should reform into, yes, the question of checked exceptions. What do we do about that? No, it's not Remy's.
So this question gets asked every year.
Yeah.
And it's a complicated topic.
Let me call up the video and we'll just...
Everybody thinks they hate checked exceptions. There was an excellent piece by Joe Duffy called The Error Model. This is a very comprehensive blog post surveying error handling techniques across a number of languages with a very honest assessment of the pros and cons of each, which I think says almost everything there is to be said about the topic. And the basic summary is there are a bunch of different ways that you can handle errors. They all suck. There is, for each one of them, you can find people who are big proponents and people who are big detractors. But largely, this is a matter of personal taste. And, there are, reasons that a language would choose exceptions. There are reasons that a language would choose checked exceptions. And I don't think it was checked exceptions itself that was the mistake. I think one of the reasons why people hate checked exceptions so much is that a lot of the early libraries that we developed overused checked exceptions. Because we didn't know any better at the time. We hadn't quite developed a good sense of when should we use checked exceptions versus unchecked exceptions. There was when this came up, I don't know, last DevOps, it comes up every year at DevOps. So in some previous DevOps, when this came up, the questioner had a somewhat aggressive manner about. It amounted to, when are you idiots going to get rid of checked exceptions already, or something like that. And that fellow was absolutely convinced that not only were checked exceptions totally a failed experiment, but everybody knows checked exceptions are a failed experiment. We did a little show of hands, and it turned out that about 20% of the audience agreed with him, and most of the rest of the audience thought that they were, well, not great, but not terrible, and it would be pretty disruptive to try to change horses 25 years later, and that there actually is kind of a silent majority that doesn't hate them. But what you hear in the ecosystem are the vocal haters. So checked exceptions were, they're not great. They're better than some of the alternatives in some cases. I think they were overused, but I think the cost of trying to migrate the I don't know how many billions, tens of billions, hundreds of billions of lines of Java code there are out there, but trying to migrate all of that code to do something different would be, the cost would be unreasonable. And so I think they're here to stay.
Okay, there's a question about deprecation, so I guess I have to take that
that's
one.
yours, Stuart.
Yeah, what's next to be deprecated? Well, so currently what's on the dock for deprecation is there's some old thread stuff. And so our colleague Alan Bateman is pushing forward with getting rid of, count stack frames, I think is one that's on the chopping block. And the reason is that in order to count the stack frames, the thread must be suspended. And thread suspend and resume have been deprecated since forever. And so we've had our eye on actually getting rid of that functionality for a while. And so I think another thing that Alan did recently was to move those to be deprecated for removal. So, and part of that ties in with Project Loom too, because the notion, there's I don't know if how much you want to say about this, Ron, but there's this idea of threads. There's the typical heavyweight threads, and then there are fibers, which are now being rechristened lightweight threads, and they're going to be unified in the same API. And so decomplexifying and getting rid of some of the old stuff from Java lang thread will make some room for that. Is there anything you wanted to add on that score?
Yeah, so like I mentioned in my talk yesterday, we had to choose between whether we want to start afresh with a completely new API or somehow retrofit the existing thread API to also work with what used to be known as fibers. And we realized that some parts of the thread API were in such heavy use, for example, the current thread method, that if we just took that away, then very little existing code would get to enjoy fibers. But on the other hand, the rest of the thread API isn't actually very much used directly by people. Most people just use executors and futures. So we realized that we could in some way have our cake and eat it too, and keep using the old, or the current thread API to represent what is now known as lightweight or virtual threads, but encourage people to manipulate them and work with them using some new API that is somehow still TBD, but will be based on structured concurrency. And that is what I showed yesterday. But still, even though people don't see the thread API in their face every day, you do look at the Java doc from time to time, and you do ask for your ID for autocomplete. And it would be nice to clean it up a bit and get rid of methods that have been deprecated for decades.
Okay, let's see. Other deprecation stuff going on.
Linked list.
Oh, linked list. Yeah, well, so there's always the possibility of deprecating some of the older collections, but to the extent that they're used, they will generate unnecessary warnings. And what we found is that people are sensitive about gratuitous addition of warnings. So I think we need to work on that a little bit more. So, all right, well, I was going to say more on deprecation, but I forgot what I was going to say because there are new things rolling in. Okay, so this question about text blocks. And so it was in preview in, I forget. Oh, it was preview in 13. It's previewed again in 14. And so the question is, why is it being previewed again in 14? And so one thing is that we are modifying it. There's a proposal that is now that Jim Lasky is now putting forth, which is to add some new escape sequences that facilitate some things having to do with text blocks, including \s, which will be replaced with a space character so that spaces can become visible, because there's some things that can, I mean, if you look at the text blocks documents, there's this issue with trailing spaces, and sometimes trailing spaces are automatically stripped from text blocks, but sometimes you actually want them there, and preserving them there is actually an issue. So we're going to press harder on the escape sequences there. And then also line continuation. Sometimes you want to add a line break. Sometimes you want to add a line break in the source code without adding a new line to the actual text. So there's an escape sequence for that. Now, did you want to add anything to that, Brian, about the idea of previewing something a second time?
Yeah. So this is something that we've been sort of searching for the right way to surface out new features, given the new release cadence. So the notion of preview features is pretty straightforward. It's a feature that is largely complete, but not yet permanent. And the reason that you want to have some amount of time between thinking you're done and declaring that you're actually done is so that you have an opportunity to get feedback from a broader audience and discover if there's anything that you missed in the design process, and have some time to gather feedback and act on that feedback and potentially modify the feature. And what we found was that previewing for 6 months only didn't give us that. And the reason for that is if you look at the release calendar, so we release twice a year. For each release, there's a engineering freeze, which say for 13, was the end of June or the middle of June. And then there's a back-end productization where GA doesn't come out till September, and that's fine. But that means that the next freeze is coming in December, which leaves 3 months to get feedback, think about it, review it, design any changes, and get them put back, which seems quite unlikely to actually occur. And so if we were serious about getting feedback and potentially acting on it, 6 months wasn't enough. And so our thinking is for features that either where we want to make a change, after the first preview, or that we think just needs a little bit more feedback to make sure that we haven't shipped to Turkey, that going 2 rounds of preview seems reasonable. It's a little unfortunate because it means from the time the feature is put back into the source control to the time a release with it is GA is like 15 months. That seems like a long time, and that part of it is unfortunate. But if there's also a risk of shipping the wrong thing and having to live with it forever, and that would be more unfortunate. So we did that with switch expressions. We're doing that with text blocks. We will almost certainly do that with records and pattern matching. It's conceivable there are features that are so small that they don't need to go through that much preview, but I guess we have evidence that means a smaller feature than text blocks is now. So
I want to say a few words about feedback. Feedback is extremely important to us for all projects and all changes and all features. If you have the time, you can use early access builds or even build the JDK yourself if you have even more time and provide us with feedback. One of the things I've heard is that people think that... So the best place to do that would be on the relevant project's mailing list. I've heard that some people may feel that the feedback is being ignored, but I guarantee you that everything you say, whether you get a response or not, will be discussed internally and is discussed internally. No feedback is ever ignored. Now, it could be that you don't like what we end up deciding, but at the end of the day, we do have to make a decision, but we do ask for feedback. You can check to see if what you're saying hasn't been asked before, but please do provide us feedback as early as you can.
Yep.
And we really do appreciate that.
And on the topic of feedback, I totally agree with what Ron said. All feedback is good, but some forms of feedback are better than others. Obviously, constructive feedback is better than unconstructive feedback. But the most valuable feedback is of the form, I tried this in real code, and this was my experience. We get a lot of feedback that I would call armchair feedback, which is, I spent 30 seconds looking at the description of the feature, and I have these comments on the syntax. Okay, that's feedback, but it's not really the most valuable of feedback. Certainly not likely to get a response because we get hundreds of those. But I tried it. Here was the code I started with. Here was the code I tried to refactor to. Here was what was good. Here's what was bad. That is incredibly valuable feedback. Obviously, bug reports are very valuable feedback. So the most valuable feedback comes from people who tried it with real code and have experience to report.
Okay, there's a general question about Project Loom. What advantages is it bringing to working with threads or whatever, and how will the programming model change? So give you a chance to give an overview plug and maybe refer people to
So
other
first of
materials.
all, I would suggest that the talk I gave yesterday is now online on YouTube. You can just watch it.
So what was the title of that talk, or is it just Project Loom?
Yeah, Loom. The word Loom is somewhere in the title.
Okay.
The main thing that it changes is that we have... So look at server applications that Java is heavily used for. Server applications are heavily concurrent. By that, I mean that they need to handle a very large number of incoming requests that come in concurrently. Every application, the application domain itself, has a natural unit of concurrency, say the request, or for some, it could be the session or the user. And the easiest way to represent that in code would be to use the software unit of concurrency, which is the thread, to represent a single domain, application domain unit of concurrency. Unfortunately, that is not quite possible with the implementation of threads we have today, because even though applications can easily manage tens of thousands or hundreds of thousands, maybe even more incoming concurrent requests, you cannot spawn 100,000 threads, let alone 1 million. You just can't, because the implementation in the kernel is just too heavyweight. So what Loom does, so what people do is they try not to represent every application unit of concurrency with a thread. They try to write asynchronous code, maybe use reactive libraries. The downside to that is that it fights both the language, so you have to recreate all the control flow constructs in a sort of a DSL, all the loops, all the error handling. You can't use exceptions. And even worse than that, it fights all the tooling and the debugging. You don't get the proper exception traces. That they don't give you the right context. It's very hard to step through that code in the debugger, and it's quite impossible to profile the code in a profiler, because profilers, at least for Java, assume that the context of what you do is a certain portion of a thread. So the best way to do it, to remove that dilemma between writing scalable code and writing code that plays nicely with the language and the platform and is easy to read, is just change the implementation of threads. So Project Loom, in addition to the existing thread implementation that we have today, it will allow you to create a more lightweight form of threads. Those would be virtual threads that are implemented and managed by the Java runtime rather than the OS, and but your code and the tooling would continue to work as they do for the current heavyweight threads. As much as that I think is the main message. We are also introducing, or thinking of introducing, a new programming model that now that threads become essentially free, you can create as many of them as you like. We want to make it easier for you to manage them. To that end, we introduced something called structured concurrency. I can't explain it to you in a few sentences, but just watch my talk from yesterday.
Okay.
So how many people are using some kind of reactive API now? All right, so of the hands that are up, how many people think that the programming model is absolutely awesome? Any hands left up? All right, of the remaining hands, how many are willing to admit to some sort of Stockholm syndrome?
More hands went up.
That's what I thought. Reactive APIs look cool at first, because they let you do something that was difficult to do without them. But the distortion that they impose on your program, eventually, the API becomes the master and you become the servant.
One thing I forgot, so we will introduce something new about managing those threads, but in terms of the basic programming model, of course, it will be the ordinary old-school style of writing synchronous code. You'll write, just as you did, say, in the 90s, you'd write straightforward linear code that blocks. It's just that if you block on I/O, from the perspective of the operating system, it would actually, under the covers, it would use non-blocking I/O, and no kernel threads would be blocked. So you're using a very convenient programming model, one you already know, but you are still making very good use of the hardware and the capabilities given to you by the operating system. So you basically get the same scalability that reactive frameworks give you, but essentially for free using the code you're already familiar with.
So I think there's a few folks in the audience that don't have Twitter on a device that would like to ask questions. I did see a few hands. This gentleman had a hand up for a while.
Based on the talk related to Graul VM, it looks almost ideal. So can it replace standard JVM?
So the question is, will Graul replace the standard JVM? So there's not just one JVM in the world. There are many JVM implementations, several of them from Oracle, some of them from other companies, and Graul VM is another VM implementation. It has some nice characteristics that some people like, and so some people may use it for that. Will it become the only JVM in the world? No, of course not. No single JVM is going to become the only one that anyone ever uses. It's got a very nice compiler. It offers better performance in some cases, worse performance in others. Depends very much on your workload. It does very well, for example, on Scala workloads. And the native image is a nice option to have if you have certain requirements surrounding startup and footprint that have certain costs that you may be willing to pay. So I think what it does is it offers you another option, which might be a great option for you, and you might want to use it. And it may not be an ideal option for you, in which case there are plenty of other JVMs out there as well.
I just want to, putting aside native image, Graul VM is a certain product that's a polyglot VM, so it runs Java and Python and JavaScript and all that. But for running Java, technically, Graul VM is hotspot. it is hotspot with a certain flag turned on that uses the Graul compiler instead of one of the hotspot compilers. And you can do that today with the OpenJDK. You can run a stock OpenJDK and put a flag that tells it to use the Graul compiler. You don't even need to download anything. It's not always the exact same version, but essentially it's the same thing. So if you're talking about running Java, not Python, OpenJDK already contains Graul. Native image is a separate story. So Graul VMs, it has certain separate features, but if you just want the compiler, it's not, for example, Graul VM doesn't have its own, Graul VM uses hotspots, so it's the same GCs as OpenJDK. So just, if you like the Graul compiler, just you can use OpenJDK with a flag.
Okay. All right. So there's a question about data classes. Somebody says, when are we going to get data classes in Java? So the new name for what are often called data classes is records. There's currently a JEP in candidate or proposed to target phase for JDK 14 preview. Do you want to add anything to that, Brian?
Yeah, so we're coming down to the end of the window for 14, it's kind of a bit of a race to see if the records JEP makes it into 14 or ends up in 15. But the short answer of when is this coming? The answer is we're in the final stages of preparing to target it now. So the feature is complete. There's a spec. There's an implementation. It's well tested. There's reflection support. There's VM support. All of that. So we're hoping for 14, but we'll know in mid-December whether we made it or not. And if not 14, definitely 15.
Okay, let's see. There's a question asking for an update on switch expressions. It's been in preview in JDK 12 and 13. What's going on for 14, and what changes have been introduced?
It's been targeted to 14, basically the same version that was in 13. It was targeted to 14 as a permanent feature. So it has graduated from preview, and it's ready to go.
Okay.
What about type inference in switch expressions? If you compare it to the ternary operator, for instance.
What about what about type inferences in switch expressions? What's your actual question?
So in the ternary expression, there were some rules regarding numbers. Is there any type inference going on in switch expressions? Does it carry its type?
So this is not really about type inference. This is more about numeric promotion. So the rules surrounding numeric promotion in ternary expressions are very complicated because they were originally complicated, and then they got more complicated when we added autoboxing in Java 5. And so there was some back and forth during the design process of, should we treat these as basically bigger ternary expressions and use the same ternary expression rules, or should we try to do something simpler and not adopt such complicated rules? And what we ended up doing, I believe, is adopted a somewhat simpler set of conversion rules with the intention of simplifying the specification for ternaries as a follow-on.
Okay.
Yep.
All right. So there's a question here. Why do the unmodifiable collection initializers map.of, set.of, and so forth, why are they constrained to a maximum of 10 elements? So since I designed that API, I'll take that answer. So if you look at list.of and set.of, then yes, there are overloads going up to 10 fixed arguments, and then there's a varargs follow-on. And so the choice of 10 was somewhat arbitrary. I chose, so first of all, varargs is actually somewhat expensive in Java. And so the way varargs works is that it gathers up the arguments, it allocates an array and gathers up the arguments and copies them in. And then typically the caller, for reasons of defensive programming, cannot use that array directly, and so it'll have to allocate another array and pick things out of it. So it's rather more expensive than we might like. And so since these factory methods are often used during a class's initialization or during startup time, they're often run in interpretive mode, and so a bunch of different performance considerations comes into play. And so fixed arg fixed arg overloads are necessary there. But from the point of view of the source code, you can apply an arbitrary number of arguments, and the fact that it binds to a fixed arg overload versus falling over to a var args call for a larger number of arguments is completely transparent to the source code. And the place where that doesn't occur is with map.of, because map.of requires different types for the keys and values. And so basically there you have to call, if you have more than 10 key value pairs, you just have to switch to a different factory method that takes a var args parameter of map entries. Okay, so here's one. So there's a couple questions. So what I'm trying to do is consolidate questions here. So if you don't get quite your question answered, it might be morphed a little bit. But there's a question about somebody's asking about extension methods. Will we get static extension methods like using the pipe operator? That'd be really, really cool. And also, see, Kotlin has things like that. So we're going to bring in more things from Kotlin. So I'm sure Brian will be able to handle that.
So I'll take extension methods first, right? So when we did default methods, in Java 8, there were a lot of people who said, "But I like extension methods, and from C#. Can we have those too?" Right? And so. And this sort of raises a philosophical distinction, right? So in Java, default methods are declared with the interface, whereas in C# you can declare an extension method that you declare separately, but appears to be a member of some other type. And we sort of had a philosophical objection to this because it undermines the perception that an API designer is in control of their API, and it also introduces an element of non-locality into reading code, right? So if I have something whose type is a list, it should be the case that the set of methods that I can call on that list is the same everywhere. But if you have extension methods in your language, that's not actually true because extension methods are contextually dependent. And that means code that you cut and paste from one place to another, even with all the types intact, may no longer work, for example. And so that was a sort of non-transparency, non-locality that felt like it was convenient in the situations where people want to use it, but it undermines the readability of code, and so we chose not to do that. And it seems unlikely that we will go back and reconsider whether we want to have have extension methods in Java. It's some people don't like that because it restricts the set of code that they can write, but everything's a trade-off. Were there other specific topics that were raised in the?
Well, no, it was okay. So the specific topic was extension functions, which you addressed. But then it's also, Kotlin has these nice features, and many people find them successful. So are you going to bring in any of those? And it mentions coroutines. So I don't know if that falls into your area.
I think Loom's threads are better than coroutines.
Yeah, and they're certainly better than async await.
Okay.
We have a physical questioner over here, yeah.
That was my question, and what about pipeline operator?
Yeah, so the pipeline operator is attractive in a lot of ways because it allows you to code in a fluent chaining style without being constrained by what sort of things that did the API designer imagine this being used in? And it has some advantages there. We actually considered it very seriously when we were developing the stream library. Because people said, well, I'd like to be able to add my own stream operations and such. But the more we thought about it, the more we felt like this is a feature. So the best known language that has this operator is F#. And it's a feature that fits beautifully into F#. It's a perfect match for what F# is. But it's really more of a feature from functional languages where you don't have objects to begin with. And if you have objects, I think the feature is a lot harder to justify. And so. Yes, it's cool. Yes, if I were, were I using it in something like F#, it would feel very natural. I don't think it's a very natural fit for Java. Similarly, the mechanism by which the pipe operator works involves basically shifting the receiver and the first argument in a somewhat fluid way, which is something that as a VM developer makes total sense, right? And the receiver is just the 0th argument, but at the language level, the receiver has a distinguished source position, and the user looks at the receiver as being something quite different from the other arguments. And in fact, we do dispatch on the receiver. We don't do dispatch on the argument types. And so something that blurs that distinction is something that I think Java developers would find foreign. And so as cool a feature as it is, I don't think it's the right feature for Java.
Okay, there are a couple questions for Maurizio, who is not here, but maybe we should toss them out and see if we can try to answer them. So one of them is, are there plans for a new reflection API? Maurizio published a manifesto for such an API a few years ago, and I'm actually not familiar with that. So are you? Okay.
Yeah, so reflection serves many masters, and as a result,
it satisfies none.
It satisfies none. It's a hard API to understand because most of the time what we want out of reflection is not what reflection thinks it's doing. So reflection is designed as class file reflection, like almost entirely, but not quite. And so the methods in the reflection API map largely one-to-one with artifacts that you will find in the Java class file. And then there are a few methods in reflection that break this rule, like get methods, which attempts to compute the inheritance, but only for public methods, and so it does a bad job, and it confuses you into thinking that reflection is about the source view of the world. And so there's a lot of discomfort around reflection. Every time we add a feature, like when we added records, we had to crowbar several new methods into reflection that didn't fit very comfortably because the class is this big garbage can of stuff that's been thrown in over the years and layered on we layered on stuff for generics, layered on stuff for annotations, et cetera, et cetera. So the document that Maurizio wrote about reflection was largely in the context of Valhalla, when we started to look at upgrades to the generic type system and carrying more type information around at runtime. And for that, something new was definitely needed. And since then, our plans on Valhalla have solidified around how we would intend to do specialized generics through updates to the class file format. And if we're updating the class file format, every time you change the class file format, there are reflection changes associated with it. So this is probably something that we will pick up again when we get deeper into the generic parts of Valhalla, probably in a year or two. So, Valhalla is actually in a pretty good shape now. We've, after many iterations of prototyping, we've come to a VM model that we think works. We think we're fairly close to a language model that works for value types and arrays of value types and erase generics over value types, but not yet specialized generics. So that part of it is sort of the next phase of the project, which will probably be starting after we get the base features shipped.
Okay, so another one kind of in the same vein is a general question, which is, what is the status of Project Panama? And so I'll take a swing at this, and of course you guys can jump in with additional information. So Project Panama is interesting because it's several disparate efforts going on at the same time. And so I think perhaps unlike other projects that are going on in OpenJDK, I don't think there's ever going to be a point where we say, okay, Project Panama has reached a state where we are now going to integrate it. There are a bunch of different things going on, and they're going to come in at different times. And so one of them is native memory access. And there's a talk about this tomorrow morning, which Maurizio was going to give, but Brian has graciously decided to substitute. So basically, that's called beyond byte buffers. And so everybody today uses byte buffers for accessing off-heap memory. And so one of the efforts in Panama is to try to construct some safe APIs around that. Safe, but high-performance APIs. to distinguish it from byte buffers, and kind of break that off and figure out if we can head that towards the JDK. So that's one of the Panama efforts. Another one is, I guess there was the JExtract stuff for foreign function interface. I don't know what's going on with that at the moment. Do you have a better idea there?
Yeah, so you can think of Panama as being this 3-layer cake, and turns out the cake is upside down from where we thought it was when we started the project. This is one of the things that happens as you start to understand the problem better. So the base layer is, as Stuart mentioned, the native memory access API, which I believe was proposed to target to 14 yesterday. And which I'll be talking about tomorrow morning. The next layer is the foreign function interface, which is basically, I have some native method, I want to turn it into a method handle and be able to invoke it through a method handle. And then the top layer is tooling that lets you go point a tool at some H file and generate something that makes it easier to build a Java API around it. And the most uncertainty is around the tooling story of exactly what are we going to deliver and how much. But it looks like the native memory API should go into 14, and we're hoping the other two pieces will follow shortly thereafter.
And then there also, I think part of Project Panama is the vector API.
Yeah.
And that's kind of independent of that 3-layer cake.
Yes, So the vector API is work that has been co-developed with Oracle and Intel, and it exposes an API for directly expressing vector computations, and then compiler intrinsics that look at this API that you would think there's no way this API could possibly be fast, and the compiler, the JIT compiles away all of the API calls and turns them into vector instructions. And it's an API that's a little bit like big decimal. So you don't have operator overloading. You have methods like add and multiply and such, but you can describe vectorizable computations using blends and filters and masks and all of the features of the AVX instruction set, and then the JIT will try to compile it down to something that runs on whatever whatever AVX instruction set you have at runtime, and this is an API, I think, for kind of advanced users because you have to direct the vectorization of the code. You will get better vectorization than you would from an auto-vectorizing compiler. There are things that an auto-vectorizing compiler can't necessarily figure out. And so if you have specific performance requirements and are willing to do a little bit more work, you can get a performance improvement on most modern Intel chips using it.
Okay.
Yeah.
All right. So that's Panama. Let's see. So here's another one. Your thoughts on how widely the module system has been adopted by companies. Are companies using it? And so, we'll take a swing at this. One of the things I've observed about modularity is that there's a lot of stuff conflated with the module system in Java 9, and there are particular changes in Java 9 that caused difficulties for people upgrading, and that might have nothing to do with modules whatsoever. But I think people say, "Oh, modules broke everything." So that's not necessarily true. There's a guy on Twitter, Christian Stein, I think it is, who's keeping track of Maven artifacts that are module ready, like have an automatic module name or something like that. And the number of Maven artifacts that are module ready are in the thousands. So I think slowly what's happening is that we are seeing preparations for module systems coming up. There are a lot of people still on Java 8 still, and so they can't actually be using the module system at the moment. But as we saw earlier, there are people who really are migrating to Java 11, and you can do that without adopting the module system, but it looks like there are a lot of dependencies out there that are starting to be module capable, and so when the time comes, it might make, it would be, in the future, I think, is still a potential for continued migration to use the module system.
So I want to make a comparison to the last really disruptive upgrade to Java, which was generics. So how many people here use generics? Okay, so good news, you all made it. But looking back in 2004, the view in the ecosystem was quite different. Like, oh my God, no one's ever going to use this. This is so complicated. You're never going to get all of these, all of these open source libraries to migrate. You don't want to have your library be dependent on Java 5 because everybody's still really using Java 1.3, right? So, in the year, 2 years, 3 years, 5 years, maybe even 8 years following Java 5, there were umpteen million excuses to not use generics, some of which were valid, some of which were excuses, but they, in the aggregate, they prevented a lot of libraries from adopting generics until 5 to 10 years later. And we kind of knew that would be the case, and a big part of the design of generics was making it so that you could migrate gradually and not all at once and on your schedule. And modules are exactly the same. So, a tremendous part of the effort around modules was, how do you migrate? How do you have mixed applications where some things are modules and others aren't? How do you write a module so that it works both on the class path and as a module? What that means is there will be some period of denial where everyone says, no one's ever going to use modules. And then, people do the la can't see you thing out there. And over time, more of the artifacts in Maven, more of the libraries out there will be modular. And are willing to express a dependency on Java 9, but a lot of applications still won't use it because they're not ready to make that switch, and that's fine. But over time, I think we will get to the point, maybe 10 years after Java 9, where it's like the raising hand situation we had here, where the ecosystem has said, yes, this is part of Java, of course, that's what you do. You wouldn't want to do it any other way. Will it take 10 years? Probably. So I think we are really quite on track with the progress of modularity. Those who want to say it was a failure, sorry, that's wishful thinking. I think, I think the adoption is exactly what you would expect for something as disruptive as this, and it's moving in the right direction.
I want to add a few things about this. So I came to the Java Platform Group to Oracle when modules were essentially done. So I didn't get to work on them at all. But regardless of how many applications and libraries actually use modules, modules were absolutely necessary for the JDK itself. For the continued maintenance of JDK, we would not have been able to split apart some modules as we have without modules. Some people said, why not just remove the packages? Then in that case, you would just get a runtime exception, some arbitrary point in program execution that would not have been acceptable. And it made the JDK more secure. Now, after learning about modules and how they work, personally, I'm certain that a very large number, a large portion of applications could actually get similar benefits from modules, namely, and there are two. One of them is strong encapsulation. If the application so chooses to put modules in place, then libraries become strongly encapsulated, and the application can make sure that it is making proper use of the libraries, and to make sure that upgrading those libraries won't cause problems. So if you use modules, you're helping yourself reduce the migration effort. That's one. And the other thing is reliable configuration. You don't get some problems that used to be called jar hell. And again, the JDK absolutely had to use them. The core libraries are the oldest Java project in existence, certainly large-scale Java project in existence. Not all Java projects are as complex, but many Java projects are. And I am absolutely certain that at some point people will realize the importance of modules, but even if they don't, the JDK absolutely needed them.
Okay, we're winding down, just a couple minutes left, and so I'll save kind of a big question for the end, which is, what's the next big thing for Java after Valhalla, Loom, and Panama? And so I'll start off, which is that there's another project running that wasn't in that list, which is Project Amber, which is the set of small, kind of small piecemeal. Not always small language features. And so you'll hear more about this from Brian tomorrow, but I think the killer feature in that is pattern matching. I think there is a huge amount of extension, and that's one thing that will change the way you write Java programs. Anything to add to that?
And pattern matching, so the first phase of pattern matching, we are hoping to get into Java 14. Same situation with records. It may make the cut. It may fall over into 15. But that's just the down payment. There's a much richer story about pattern matching that we will be rolling out in phases. It showed up as an interesting interaction with the serialization talk we did this morning. It shows up as an enabler for a number of other things. And so it's a pretty rich story that's going to play out over the next several years. So there's quite a lot going on. We have no shortage of things to work on.
Personally, one of the projects I'm most interested in is called Project Metropolis, which aims to gradually write more of the VM in Java. And I think it could bring many opportunities.
Okay. We're out of time. Thanks for all your questions. I hope you found it interesting.